Hey guys, so this morning we are picking back up in our series on learning programming. And the last time, the main thing that we did was reading in lines from a file and then processing the lines. So we had used this function called readline here in Python, and then we'd written a function that takes in the line and adds it to a dictionary, and we trimmed some stuff from the line. So we split the line on a comma because we had been using a comma separated value file, and then gotten the name of an item. In our case, we were using a file here. If we go look at the file tree, that's mostly like sports equipment here. And so each line has an item and then the cost of the item. And we'd been doing that for the purpose here of, where are we here? Of calculating the prices of items here. And, or sorry, that's what you would use this for in a production environment. But anyway, we read in the items and their prices and then built a data structure for us to be able to use in Python for them. So that's what we did. This was our iteration example here, because you can see that we have a loop where we go through all of the lines that are defined. So until we hit the end of the file, which is blank, and then we add each line to our dictionary here. So we're going to do another example of loops, another use case for them that's common in how loops actually end up being used in the real world. I mean, loops are used for everything, of course, but I mean, I'm just trying to give some greatest hits here for some of the ways in which you can expect to use these things when you're doing things in the real world. And so that is going to be this idea of the event loop. You don't necessarily need to memorize that word. That is probably a common enough way of thinking about it, or the main program loop. When you have a software program, you think of something like the browser that we're in right now. Well, what is actually going on somewhere in the code base is that you have a big loop. As long as the program is open, so you might think of this in terms of variables as while not closed. And if I press that button, you might think of it as we set a Boolean variable to true, and then we exit the event loop. We exit whatever loop the program is running to handle all of the things that go on when we have this graphical user interface open. And so I actually don't know exactly how browsers work, but they work something along these lines. And so if I were to go and I wanted to go click on this tab up here in the browser, this is the first tab in the browser having the display of me testing all of the slides preprocessor that I'm writing in Python. This is the second tab. This is actually connecting to a localhost instance that I don't have running right now, but when I click on this tab here, it's going to be setting a variable somewhere for which tab to display. And then based on the contents of that tab, it will switch to, whatever should be displayed here on the screen, right? And what's displayed on the screen is composed of HTML, which defines the structure of the web page, the contents, CSS, which displays how it's displayed, the style of the web page, and then JavaScript, which defines the functionality. So if I go several slides back, you see this footnote here that pops up and goes away. Well, of course, I imported a library. I wasn't clever enough to just make this all from scratch on my own. But this is exactly how the browser renders things, but you have some variables keeping track of which tab you're on, information related to the tabs, all of these things like extensions. Well, when I click on one of these, the browser is saying, hey, the user clicked on this element. And because the user clicked on this element, something happens, right? This interactivity is all happening because there's some main loop here that is running and is waiting for the user to do something. And when we say waiting for the user to do something, doing something might mean, for example, that I hover over a link. If I hover over a link, you see in the very bottom right part of my screen, we have this thing that shows me what the URL is. I don't actually know what that is called, but that's common behavior. Or, maybe if I hover over, oh, you can also see that the cursor changes, right? That's the operating system's event loop, not the browser. But, when I hover over something I can click, we turn from a pointer into a little finger that says, hey, you can click this. So all of these things are running in this loop where we're waiting for user feedback, we're waiting for interactivity, something to happen. And these event loops, these loops where we're sitting there waiting for the user to do something, well, that's what we're going to take a look at here. Now, of course, we're not going to actually write a full-fledged graphical user interface in the same way that the browser does, but hopefully I just blew your mind a little bit, is that that's really what programs are. You sit there and you have a loop, and while the user's doing stuff, and while they haven't exited the program or pressed Alt F4 or done any of the other ways in which you kill the process, you press the close button and so forth. While they haven't done those things, you want to wait for them to do things, and then depending on what they do, you'll execute different functions. So it is simplifying it a little bit, but most programs are really no more than a glorified while loop with a bunch of conditional if statements depending on what the user does. Of course, the bigger programs get, the more complicated they are than that. But at a high level, that really is how most software programs work, even those with graphical user interfaces. The big difference between a graphical user interface and something on the command line is it's a little bit less obvious that when you press a button, some code's going to be executed rather than when we do it in the terminal, as you'll see in just a sec when we do our examples. Because we will get into graphical user interfaces. I've harped on it before. I really wish that they were taught more in programming classes from the very beginning, because no matter what system you use, an important part of it is going to be user interface design. Basically, how is a user going to interact with my software product? So if I put this text in the button, is it confusing? Do they know what it means? Are they able to figure it out without me having to write a really lengthy explanation document for everything? Or if I put this link in this menu, is that the place that they'll look for it most intuitively, or will they look for it somewhere else? All of the things that I'm telling you right now, interface design, user experience, this is something that you have to kind of pick up. Now, in some big companies, there's like an entirely separate department for this. Those people study human-computer interaction. They study ways to make the interaction that users have with the computer systems a more optimal, more streamlined, better for the average user. But I don't know. Maybe we're not big enough, or well, that's just not how my employer does it. So we as software developers, we have to think about all this. We have to think about how we design our interfaces and stuff. And we're not going to get into all that today. I'm just telling you user interface design and doing the graphical front end part of designing these loops that we're talking about here. Well, that's an important facet. But just to simplify things, what we're going to be doing is we're going to be doing an event loop, but we're going to be doing it where the user interacts with things through the interpreter here. And so this is a very common program to write for introductory programmers. You have a set of things that you want to do, and you want the user to be able to pick between them. Because so far, all of the functions and things we've written, everything we've done doesn't have any interactivity with it, right? The user can't change what's happening on the fly. And we're going to change that right now. That's what we're going to be doing. So after this, you'll be able to write interactive programs, albeit on the command line, which isn't quite as exciting as with an actual interface, but you'll be able to actually interact with the programs you write. And you'll see what I mean in a second here, once we pick up more formally doing this. So what I'm going to need to do, we can put those over to the left. Those are our practice problems that we'll get going on once we finish the last couple things that we have to clean up here. Well, I'm going to look at how to read a value in from the interpreter Python. So I know how to do this. Well, at least at one point, I knew how to do this more in like Java and C# and stuff, but taking input from console. So that's what we want. We'll see if this link is descriptive here. So we have this thing called the shell over here. I'm not going to get into exactly what a shell is and how it interacts with the operating system. But at a high level, we want to be able to read something that the user takes in and then do stuff with it. So looks like to take input from the user, we make use of a built-in function called input here. All right, so input, that's good. So now let's just go and let's scaffold the framework here of a function that we're going to call. We are going to call the function like my program loop. And right now, it's not going to take in any arguments. So the first conditional statement we're going to have is that if the user input is add, now we're just going to print add. And if the user do you follow what this function is doing?
Yeah. It's taking
So,
an input from the user and putting it in the variable user input, and then checking to see if the input is add or subtract. If it is added, print it. If it is subtracted, print it.
yep. So pretty simple. And when we run this, this is our shell over here. See, what's kind of confusing is how about we add a print statement? This is why it took me a second there. How about we add a print statement that says print, and then this is an important thing. What you saw me forget there is I didn't prompt the user for anything. So what we just had was that you get to this part right here, and the shell is waiting for your input, but it didn't say so. It just stops there. That's what I mean about confusing interface design, if you will. Because how's the user supposed to know that they're supposed to enter, add, or subtract if they just get there in the program and nothing happens, right? So, we have a certain set of collective, just inherent knowledge of how you use computers. And so, for example, you see this thing over here, this button. What happens when I click that?
It pulls up a menu.
Right, pulls up a menu. However, arguably, as a human, why does 3 lines equal a menu? This is the so-called hamburger menu. A lot of graphical interface designers hate the hamburger menu because there's nothing about it that inherently screams, hey, if I click this, a menu will open, right? Like there isn't. If you think about it, it's completely arbitrary. However, it's used so often by so many sites across the entire realm of computers that now, for whatever strange reason, people say, oh, if I click the 3 horizontal lines, a menu will open up. People know that. However, why I said it annoys user interface designers is because there's no reason why that's true. It just is true. And it's used enough now that you might as well throw up your hands and just accept it, because that is just, people know that now. You click at the horizontal lines, you get a menu. But that is why they can get away with not prompting the user to do something like, hey, would you like to open a menu? Is because, well, people are supposed to know that that is how you get to the menu. And these things that are icons that do stuff, this is another really common one. You see the gear icon? Gear icon equals settings, very, very normal, right? So if you see an icon with a gear, you know that when you click that button, you're going to get something relating to settings. But most of the time, especially if you're writing a program where what you're doing isn't as obvious, you're going to have to tell the user what it is you're doing, what it is you need them to do for various things to happen. So what we're going to do here is we're going to print a statement, and we'll say would you like to add two numbers or subtract? Right. Adding and correct. Okay, so there's our string. It says, would you like to add two numbers or subtract them? Type add for adding and subtract for subtracting. Right, so it's descriptive. It says exactly what the user needs to do here to either add a number or subtract a number, right?
Mm-hmm.
And so now we're going to say add. Okay, so that's well and good. Now you might be asking me right about now, okay, Stephen, where's the loop, right? Because you don't see a loop here, right?
Yes.
So quite simply, we are going to write the loop. I'm going to add one more case here. We're going to say if user input equal it, the user input is equal to exit, we're going to print out the string goodbye. And then now we don't have a loop, but that's what we're going to do in just a second here. So we can wrap all of this. We can give the initial user input an initial value. We'll give it, what should we do here? I'm trying to actually think about best practice for, well, we'll just give it the, let's write the loop first, and you'll see why I'm thinking in just a second. So we'll write the loop. We'll say while user input not equal to exit, right? So while the user doesn't say, hey, I want to exit the application, we're going to have all of this. Okay. And I guess this will work. I guess we'll just leave it as blank here. What I was thinking about is we have this condition that checks based on the value of user input. And when we first start the program here, the user is not going to have inputted anything, right? So now, if we do this, we expect to be able to interact with this program in a loop. And we also expect to be able to type exit to exit the program. So let's see if we've done this correctly. So if we run it, this means that we are now inside the loop here. And so if we type add and press enter, it says add, and then you see how it prompts us again. So yes. Now we're in a second iteration, and now we're going to type subtract. Okay. Now it's prompting us again, right? And if we type exit, now we're done. So yes. Any questions on the basics of how this works?
What you just did. Mm-hmm. The explanation earlier was a bit involved for me, but what you just did makes sense. I understand it. So basically, you create a program that keeps running until you do something to stop it from running.
Mm-hmm. Yeah, I didn't mean to get super involved in the interface design stuff, but what I was trying to tell you was that all computer programs are like this, with just a little bit more complicated. I don't know if you've ever seen like the memes on the internet that's like about a person drawing a horse, and it's like step one, you like draw the body, step two, you draw the legs, and then like step three is like finish. And then you have this very childlike, drawing of like a circular body and stubby legs. And then after part three finish, you just see like this beautiful, majestic painting of the horse or whatever. You know what I'm talking about? Yeah, well, that step three finish, we're leaving a little bit of hand waving here, but actually all programs, including this browser that I'm running, including all of these other programs like File Explorer or Zoom or whatever, all they're doing this process here where you have some loop that waits for the user to do something. And then based on what the user does, you do different things. They're all doing that just in a much more complicated way. So
Okay.
that's the point I was trying to make, was that if you understand what we're doing here, most all computer programs are basically this, just with extra stuff on top of it.
Okay.
And the reason why I'm emphasizing this point so much is because what we're adding right now, that thus far in our discussion of programming, we haven't dealt with, is the idea of interactivity. So the idea that we are writing something that a human being wants to be able to interact with, because otherwise, if they just every time they press run, it does exactly the same thing. It's not very useful, right? It doesn't let them change the outcome of things. Okay, so we want to clean this up a little bit. You see that a part of this is just that this screen is kind of small here, so it doesn't wrap as well. We can get rid of the file tree for now, so we have a little more room. But one of the things we want to do is we probably want to add a new line between when the user would add input and when they wouldn't. Okay, so to do that, we add a /n here. That's an escape character. So if you add a \n to a string, it will print a new line when it gets printed. Okay, and the other thing that we'll probably want to do is, after we print out the response to each one, we'll probably, or actually, you know, let's be consistent. We'll do it this way. We'll probably add a new line there as well. So we're going to add new lines to all of our strings. And then we can be a little bit clever. If you remember, there was a way to print something. Okay. And then I think we have, I think we're going to say that end is going to be equal to the empty string there. And that will mean that we don't print a new line here. And you'll see why I'm doing this in just a second. Actually, it's more efficient to do it there. You know what, let me comment that out for a second, and then we'll talk about it. All right, so let's see what happens when we run this now. So now you see we got here in the loop. We're now printing the prompt here. Now we have a new line.
Yeah.
And I want to show you why I did what I just did, because I actually made an error here. So the intention was, with this line of printing an input, we wanted to print the word input and then a space so that the user would know, oh, I'm inputting something right now. Okay.
Yeah.
But the problem was I put it inside of the conditionals after they've already picked something. And so they're going to say add, and then the next line is going to say add and then input, right? So this is an example of just this is the sort of mistake that you'll make and you'll be like, oh, well, no, duh. You know, that's me being silly. But I mean, I even started writing this and then I just finished it so I can show you. But how would we fix this? This is why I left this in here. So we want to prompt the user before we ask them for input, right? So where does this line that's asking them for input, where does it need to go?
It should go. It should go before the conditionals, right?
Okay, so is it just before the conditionals? Well, I mean, let's try it. Let's see what happens. So at least this will be before the conditionals, like you said.
Yes, yes, but it should go before user input too.
Okay, right. And so to verify that, let's do this right here. So if this is just before the conditionals, but not before the input statement, well, we're still not getting it, right? Then we press add, and then we get still prints, right? Now, this way, we didn't have to print it in each and every conditional. So that's still useful because now we only have one of these rather than three. Still better code practice. Don't duplicate yourself. So actually, the coding principle there is called don't repeat yourself. Acronym DRY. You want to keep your code dry. You don't want to repeat yourself unnecessarily. So if you're doing something multiple times, that means that you should pull it out. You should put it in a loop, something, so that you're not hard coding the same thing multiple times. But that's still not what we want because we want the prompt here. And so we're going to print this before the user input, like you said. Okay, so now when we run it, aha, now you see it's telling us input something. And now you press input, it prints it like that. Okay, so.
I see that now.
And now this is much easier for the user to follow what's going on. And oops, you see, this is what happens when you miss the new line there, right? See, I missed that new line. And that's why that doesn't look as good. So, and unfortunately, this time we got stuck because I put the new line in the wrong place. So this is why, well, I'll talk about this in a second here. So this new line needs to go on subtract instead when we print. And we just got stuck because the user didn't enter anything here, right? Or they entered exit with an, you know what? Well, let me come up with a better example. Let me show you. Ignore what I just said. We'll get to that in a second. Let me convince you now that I just fixed what we did. We said add, okay, subtract. Now that we moved that new line, that was a typo. Okay, and then exit. Our program works as we expect it to, right?
Yes.
So what happens now? What happens if the user tries to enter something that's not one of these three? See, we don't have any case in our code to handle it, right?
So it doesn't do anything.
But will it go up to the top of the loop?
I think it will error out. I don't know. I'm not sure.
All right, well, let's try it. So let's say we want to, something that we haven't done yet. So you see right now that if we try to do something and the loop doesn't handle it, right now it just sticks us right back up to the top of the loop, right?
Okay, okay.
Now, among other things, you see that we don't have a space here, whereas we kind of want a space there, right? But really, in proper programming design, you don't want errors to happen silently, right? Because if I'm a user and I say, I want to multiply, why isn't it letting me multiply? What the heck, man? You know, like here's this program. I mean, of course, if you write your instructions well, every single time the user enters this word, it means that they're ignoring your instructions. However, something that you'll come to do, you know, I'm telling you how it is, shooting it to you straight. Something that you'll realize very quickly is that just because something makes sense to you as a software developer, or, you know, you would think it's common sense. It's, you know, like, well, obviously in a program that adds and subtracts numbers, you wouldn't try to multiply. Guess what? The very first thing users are going to try to do is they're going to try to multiply, right? And so if you have the clearest, most concise, beautiful instructions in the world, you know what users are going to try to do as soon as you give them the application? They're going to not do that. And it's something that amuses software engineers a lot because, I mean, let me let you in on a little secret here. Software engineers talk smack about users all the time because they always seem to find ways to break our code. No matter how good you think you are, no matter how comprehensive you are in testing your own code and in handling cases that you say, haha, well, if they do this, there won't be an error. They'll still manage to find ways to break it. And usually it's not because you did your job so poorly that it doesn't do what it's supposed to do if they follow the proper set of steps. Usually it's they did something completely off the wall that you're like, why would a sane person ever do this? But if they are able to do it and your code breaks, that's still on you because you need to be handling the cases even when they do things they're not supposed to. Otherwise, if you get a big red runtime error when your code's executing, then the users are going to complain to, you know, their boss that, hey, boss, the program's stupid and it broke, and then it's your fault. Yeah, I'm telling you, this is how it really is. So what I'm telling you is that even though in our application where we say here, hey, would you like to add or subtract two numbers? Emphasis on add and subtract. Well, the user's still going to try inputting multiply because they're a user and users are dumb. And like I said, I'm telling you, this is how it is in the real world. It's not that we as programmers categorically hate all people who use our software. but you will learn quickly that they are the people who will best uncover bugs in your own program. And not just bugs, they'll encounter, shall we say, interesting situations that you never thought of, because the interesting situations have them doing things that they shouldn't be doing. But nonetheless, this is simply a fact of programming. You need to get this through your head that you have to handle every single possible error case there is, in addition to all of the success cases. And so by error case, I mean, if the user is trying to do something that they shouldn't be doing, you shouldn't let them do it. And when they try to do it, it shouldn't break your code. You see what I'm saying? Every single thing that can be done, you have to handle gracefully. And so gracefully in this case means that we're going to put an else here, right? So if the user does add, we print add. If they do subtract, we print subtract. If they do exit, we print goodbye, and we break out of our program. And if they enter absolutely anything else, what we're going to do is we are going to say, please, oops, not just string, we're going to print this. We're going to say, please enter a valid option. Try it again. Okay, so now we're going to tell them, hey, the thing you just did is not valid. So try entering something else. And for good experience here, we're going to add a new line too. Okay, so now let's try. So now if our special user decides that they want to multiply in the program that's supposed to add and subtract, we say, please enter a valid option, try again. And it kicks us right back to the loop where the user is entering input. Are you tracking so far?
Yes, I am.
Okay, so you too will be able to insult users once you become a software developer. It's one of the perks. It's this way of looking at the world where very suddenly, once you start designing software, it kind of becomes an us versus them thing. When you think like a software developer, it will actually annoy you when you see other developers not do this in their code. So if you've ever gotten a big nasty error message when you try to do something, well, for normal people, it's kind of annoying, but for software developers, it's like you'll kind of grimace and you'll be like, you'll salute the people and be like, you, sir, need to fix that, because otherwise someone's going to get on you about it. One of the ways in which this problem gets handled out in the real world is that we try to test each other's code so that before a customer or whoever's paying for our project, before they ever see it, we will, as software developers, we will have tested each other's code so that hopefully we've handled all these cases. Because once you start thinking like a programmer more, once you start thinking like a developer, what you'll start doing is you'll start running through all the permutations, all of the ways in which a user might do something they're not supposed to do, and then you'll try them, and you'll make sure that they don't break things. And software developers think like this, it'll become second nature to you. What are all of the cases in the code that I'm writing? Have I covered every single case? So here we have 4 cases. We have the case that what they enter is the word add, that is the word subtract. Why does that keep getting moved? Ugh. I don't know if I goofed again. You should print the new line there. It's add or subtract or exit, or it's anything else. This covers every single possible case that they could do, right? There is no possible thing they could enter that isn't handled by our code. That's usually the situation you want to be in. Everything is handled. There is no way for the user to do something that you don't have a say in what happens after that. Okay, so the next thing that we want to do is we want to implement these functions here called add and subtract. Now, just to save time, because I got to go to work, I'm just going to go ahead and write them, but I'm sure you can take in 2 variables and then add them or subtract them. That's like hopefully easy peasy for you now, right?
Yeah, it's absolutely.
So we're going to make a function here. We're going to call it add numbers, and it's going to take in num1, num2, and then we're going to return num1 plus num2, right? Make sense? And then we're going to do the same thing. Subtract, except rather than calling it add, we're going to call it subtract. And then we're going to do num1 minus num2, right? Okay. So now we're going to print enter two numbers. Will be added. Okay.
Yeah.
Okay, so we're going to get number one here. And then after that, we get number two. New line there. And then we're going to call a function here with the things that the user inputs. Make sense so far?
Yeah.
Now, there will be a problem that comes up when we do this, and you'll see what that problem is in just a second. And so what we're going to do is actually, after we do this, we're going to do one more print statement. We're going to say result the addition is all right. So let's run again. Okay, so now we want to say add. Let's see what happens. Well, typo is what happens, but say number one is 3, and let's say number 5 is 5. Well, nothing happened there. Interesting. It's because I didn't print anything. That'd be why, right? So well, let me think about the best way to do this.
You were supposed to print something.
Yeah, well, I didn't. I say I called this, but I never did anything with it. So I think the easiest way to do this will be to use a format string. So if you put the letter F in front of a string in Python, then anytime you use curly brackets, whatever's inside the curly brackets won't get, it won't be a string, but you can actually put code that returns values inside there.
Okay.
All right, so let's see what happens now when I do that. We're going to say add, oops, I'll add number 1, we want to be 3, number 2, we want to be 5. So it says it's 35. Is 3 plus 5 35?
No, it's adding them as a string.
And so this we want to be a number. So how should we make this thing that we're getting from the user? How should we make it a number?
We can use int before. Yes.
Okay, like this.
And
we can also note that based on what we're doing here, that we're not adding a new line at the end, and we really probably should, right? And so
yes,
we're going to stick a new line there as well. Okay, now let's try. So we expect that the addition here should be 8, not 35, right? So
yes.
First input is going to be 3, second input, oops. Oh, no, we are on, okay, there we go. So 3, 5, there. Actually, interestingly, because we said end is going to be blank here, that's why we have our plug. We don't need that anymore. Okay, so first off, let's get rid of our typo.
Can you explain again what the end code is about?
What this right here?
No, I mean where you have end equals empty string.
Oh,
in the
this.
print statement.
Okay, yeah, gotcha. Okay, so by default, when you call this function right here, you see this line right here? If you just have as a line in your code, print open parentheses, close parentheses, it prints a new line. And that's because by default, whatever string you pass the print function, it will concatenate a new line on the end of it before it prints it out to console. And so I added this statement right here to put this, you see this new line right here? So
Yeah.
would you like to add two numbers, blah, blah, blah. Well, when we say add there, then immediately under it, we do this print statement because the user presses enter, right? So one new line happens when the user presses enter, but we don't have another one there. So I'll show you what I mean. If I add a print statement right here, then there will be a space after add, and then this line here to enter two numbers, because print inherently adds a new line. And if there's no string there, well then, you see, now there's a space.
Yes.
So that's the default behavior of print. And so if we don't want print to add a new line, we have to explicitly tell it not to. And that's what this says. This says end,
Okay.
which represents the whatever print adds to the end of the string. Now, mind you, if we want to put an exclamation point after everything, we could do that too. So if we change this to exclamation point, well, it's not going to be nothing here. We're going to say number one, exclamation point. I'll show you in just a second. We get to control what the end characters are for the print. Okay, so see, exclamation point.
I see that.
So we get to control. And so if we set end to the empty string, then it's not going to terminate what it prints with anything. And like I said, by default, the default call to print is equivalent to this. It's equivalent to having end be setting to the new line character.
Okay.
Does that make sense?
Yes.
All right, so I've got about 10 minutes, so hopefully I'm not going too fast here. But now this means that we've got our first case done, right?
Yes.
So input add, and then we pick, it could be any two numbers, right? It shouldn't just be 5 and 3. So the result of the addition is 14, right? Tracking so far? So now we want to go do the same thing for subtract, right? So that was our add case here. Now, you know what we're going to do is we are going to go ahead and just copy all of this. And this is going to be pretty similar. So we're just going to paste it here. Okay.
Okay.
Except we're going to want to modify our thing. We're going to want to modify our message. We're going to say the second number will be subtracted, because unlike in the first one, addition is not positional. If you add two numbers, it doesn't matter what order you add them in. However, subtraction is not. The order in which you subtract things is important, right? And so here we're going to tell the user that the second number they enter will be the one subtracted from the first, right? Okay, so we're still going to read the numbers in as integers. We're still going to print something, except rather than addition, type in subtraction, right?
Mm-hmm.
And rather than add here, add numbers, we're going to say subtract numbers. Okay, and if we did our subtraction correctly, then that's all it should take. You see how fast that was?
Yeah.
Because we already had all of the structure in place, and so we just had to tweak a couple things. Well, let's see if it works. Okay, so now we're going to do subtract. Okay, still numbers, so let's try 5 and 3. Now this should be 2, not 8, right?
Yes. I see.
Questions?
I was going to ask how to code it so that it always puts a space after you're done. Like before it prints, what would you like to add or subtract numbers again? You know, but somehow you did it, and I'm not really sure how you did it.
So you want to know, where does the new line here? So you see the result of the subtraction is, you see this character right here?
Yes, I see that now.
That's where we're adding the extra line, because one line break is the difference between having this text just carry off the end of this line here versus end up on the new line. But you remember when I was telling you, if we have a string that's like string equals, some text, and then you have a new line character, and then you concatenate that with something that's blank, and then you concatenate it with another new line character.
Yeah, you told me about that.
Should not mix. This is essentially what happens when you concatenate an extra new line onto the end of something. It's like you're saying, I have another line, but there's nothing on it, and so just go straight to the line after that. That's what one of these blank lines is. It's an empty line. It's an empty string with a new line on the end. And so there's all of this has a new line at the end of it, and it has that because because we put a new line on this string up here. See this one?
Yeah.
So if we were to remove the new lines that we have here, we would go straight from the end of this string, and then we'd go down to the next line, and then immediately we'd go to input. However, I think it looks better if we have a space there. And so when you stick a new line on the end of the string like this, remember that we're printing, but we're not setting the end character to anything. So because of that, print is going to inherently have a new line, but we want to add an extra new line. And that's why we've added the extra new line characters there like that. And so that's what's causing the extra lines here. Good question, though. May seem like magic a little bit.
Yeah, I get it, but I'm going to have to do some practice to have it sink in completely.
And for the record, we went through this pretty quick today. Like what I just wrote here for me, like this whole have an event loop, have the program do stuff when you're in the loop based on what the user picks. This is usually like a programming project in an introductory programming class, and students will have like a week or something to do it, or 2 weeks or something. And
I see.
We did it in like 30 minutes. Okay. Hopefully the concept isn't so bad.
It's not I get it conceptually, but I want to get used to it by actually working with it. That's what I'm saying. Understand it completely.
And at some point here, the other thing that I was thinking, I don't want to scare you, but it might be good for us to try to give you like tests and stuff, quizzes. If you're familiar with classes in general, students usually don't like tests too much, but they're actually helpful because they help you show how you're doing, right? They're a way to measure.
I love the idea.
They are a way to measure how well am I tracking the materials that I've learned. So we'll give you some time. What I think would be good is, okay, so we did addition and subtraction. What happens if you want to add more cases here? How do you do that? You'll also see something here that our code is getting pretty long, right? Remember, did I ever tell you that one of the principles we want to try to abide by is to not have a function become longer than a screen length, right?
Yeah, you did. You told me
this
that.
function's getting longer than a screen length, right? So some later time, we can come up with a way to see if we can figure out how to make all of this smaller. But I have to go to work now, so.
Okay, sure.
This was our example today here. Another example with iteration, and you see our loop here is we are checking the user input, and as long as it doesn't equal exit, then we're going to keep going in our event loop here.
Okay.
All right, well, we'll have more practice later. Something else that we didn't cover here today, which we will cover perhaps next time we meet, is what happens if what the user gives us here for the thing, well, what happens if it's not an integer, right?
Yes.
Actually, I'll show you sneak preview of what happens. Like, let's say we want to add, but then the first thing that we give them, let's say they type out the number, right? So Python's not going to think that's an integer because that's a string, right?
Yes.
Angry red error, right?
Mm-hmm.
Right now, that completely terminates the code, right? So if you're a user, and like I said, remember, users aren't going to think like you. And so if I'm a user and it says, would you like to add two numbers, add or subtract them? If you type add for adding, subtract for subtracting, I'll just say, I want to add two numbers. Enter two numbers. The two numbers will be added. So if I'm a user, I say, well, okay, I'm going to type out the numbers because that's normal, right? There's actually nothing wrong with that train of thought. And so what happens right here is they type in a number and then everything screams at them in red and they're like, well, why? I did what I was supposed to do. right?
Yeah.
So
Yeah.
we're going to have to figure out a way, how do we handle this, right?
Okay.
And that's when we pick up, we will talk about exceptions. And this right here, this is an error. This is an exception. And rather than
Yes.
having your code screech to a halt and show the user this angry red message, you can actually do things. If the user tries to do something and it causes one of these, you can quote unquote catch it. You can say, uh-oh, the user tried something. Let me do something if what they tried leads to an exception or a specific kind of exception. But we'll get to exceptions so that you can handle messages like this so that your program doesn't just terminate with the user having this message presented to them.
Okay.
All right, well, we will talk more later, and I think that's where we'll cut for today.